Hi everybody, welcome to Notes 4.6. Today we are going to be talking about completing the square. So why do we use the completing the square method? Well, we use the completing the square method to solve quadratic equations when the quadratic is not factorable. We can also use completing the square to change standard form to vertex form. Let's jump in and look at our first example. X squared plus 6x minus 11 equals 0. So we're going to show you two examples today on how do we complete the square when a is 1, and then we're going to show you one example on how to complete the square when a is not 1. So I promise you, if you follow these steps and you do them in order, you should arrive at the same answer that I get. All right, so the first step to completing the square when a is 1 is that you want to move the constant to the other side. I know this is contradictory to what we told you about solving quadratics, where they always have to equal 0, but this is a little way in which completing the square is different. So we're going to kick that negative 11 to the other side by adding 11 to both sides. That gives me x squared plus 6x plus something equals 11 plus something. So at the end of each equation, we are going to place a box. Those boxes are going to hold what we call the magic number. That's the magic number that's going to turn the right side into what we call a perfect square trinomial, meaning it's going to be x plus something times itself or x minus something times itself. So, well, how do we calculate this magic number? Well, to calculate the magic number, you are going to take b divided by 2 and square it. You want to do the b value divided by 2 and square it. And then we're going to add that to both sides of the equation, because remember, what we do to one side of the equation, we have to do to the other. So my b value is 6, so I'm going to do 6 divided by 2 squared. So 6 divided by 2 is 3. 3 squared is 9. So I'm now going to put 9 inside each of the boxes. Excellent. Now what we're going to do is we are going to factor the left side, because now we've turned it into something that can be factored. So we're going to factor the left side and combine like terms on the right side. So I need two numbers that multiply to make 9 that also add to make 6. Two numbers that multiply to make 9 that add to make 6. 3 and 3. So that's going to be x plus 3 times x plus 3, and then 11 plus 9 is 20. Now, when you get to this step and you see a parentheses times itself, okay, so when you see and you're completing the square, when you see a parentheses times itself, you want to turn it into that parentheses squared. So we're going to turn x plus 3 times x plus 3 into x plus 3 squared. Okay? Now that we've got x plus 3 squared equals 20, we simply solve for x. So how do we undo the square? Well, that means that we take the square root of both sides. So I'm going to do the square root of x plus 3 squared equals the square root of 20. Now, on the left, I get x plus 3, but 20 is not a perfect square. And we have to put plus or minus because we put the radical there. If we put the radical there in the course of solving, our answer has to be plus or minus. So, again, 20 is not a perfect square, so I have to break it down to prime factorization. So 20 is 2 times 10. 10 is 2 times 5. So we circle the two 2's because 2 times 2 is 4. And what is the square root of 4? Well, the square root of 4 is 2. So 2 gets to come outside of the radical. 5 doesn't have anybody to buddy up with, so he stays inside the radical. So that gives me x plus 3 equals plus or minus 2 square roots of 5. Now I just keep going and I solve for x. Well, how do I undo addition by 3? I subtract 3. And so my solution is negative 3 plus or minus 2 square roots of 5. And that's as far as you can go. Now, let's look at this. What if they ask me to complete the square to change to vertex form? What if they say use complete the square to change standard form to vertex form? Well, guess what? The steps are the same to get to x plus 3 squared equals 20. So all the steps that we did on that slide before to get to x plus 3 squared equals 20, you do the same steps. Where it changes is instead of solving for x at this point, we are now going to bring the 20 back over to the other side and make it equal to y. So we're going to move the constant to the other side and we're going to set it equal to y. So I subtract 20 from both sides and I get y equals x plus 3 squared minus 20. All right, so again, the steps are the same. It's just instead of solving at the end, you're going to move that constant back over and smack on a y equals. That's all you got to do. And that's vertex form. Okay, let's look at our next example. X squared minus 3x plus 3 equals 0. Now, the steps to solve this are the same. Our first step is we're going to move that constant to the other side. So I'm going to subtract 3 from each side. And that gives me x squared minus 3x plus something equals negative 3 plus something. So step 2 says I put a box at the end of each side of the equation. This is going to hold my magic number. Okay, this is going to hold my magic number. So to get the magic number, we do b divided by 2 squared. Well, this time my b is negative 3. Negative 3 is not divisible by 2, so we leave it a fraction and we square it. And I get 9/4. So 9/4 is what goes into my magic box. Now, I have to look at it and I have to say, what two numbers multiply to make 9/4 that also add to make negative 3? Negative 3 halves. So if I make that x minus 3 halves and x minus 3 halves, that will multiply to make x squared minus 3x plus 9/4. Now, I know you may be thinking, well, negative 3 halves times negative 3 halves. Yes, I know that multiplies to make 9/4. But are you sure it equals 3? Well, let's check it out. Negative 3 halves plus negative 3 halves is negative 6 halves, which is negative 3. So, yep, it works. Now, let's say you have trouble coming up with the magic number. I want you to look at something. Look at these two values again. Okay, so sorry I didn't circle the whole one here. But look at both of these values. Does that look like something we've seen before in this problem? Yes. So whatever your x minus and x minus or x plus and x plus is always going to be the same as b over 2. So that should give you a little hint to help let you know you're on the right track. So this is really x minus b over 2, x minus b over 2 if it's negative, or x plus b over 2, x plus b over 2. So that is not a coincidence that they are the same. So that will help you in your factoring sum. All right, so now you're probably thinking, okay, so like, wait a minute, slow down, negative 3 plus 9/4. Well, we just combined like terms. So I have to get a common denominator. So 4 times negative 3 is negative 12 fourths plus 9 fourths equals negative 3 fourths. So that's how I combine my terms and to simplify the right side. All right, so something times itself means that that is something squared. So x minus 3 halves squared equals negative 3 fourths. Now, since I'm solving, okay, so here's kind of where we hit the fork in the road. If we're solving, we take the square root and simplify. But if we're changing to vertex form, once we get to this step, we're going to bring the constant back over and set it equal to y. So, but for now, first of all, we're going to solve. So I do that by taking the square root of each side. So when I look at the left side, that just becomes x minus 3 halves. But when I look at the right side, I end up with the square root of negative 3 over the square root of 4. Now, I know that I can't have the square root of negative 3. So if you remember, that becomes the square root of 3 times the square root of negative 1. So that becomes I square roots of 3, because you can't simplify it. And then the square root of 4 is 2. So that gives me x minus 3 halves equals plus or minus I square roots of 3 over 2. Now I just continue on solving for x. So I add 3 halves to both sides. And that gets me x equals 3 over 2 plus or minus I square roots of 3 over 2. Now, you may be asking, well, couldn't I just say 3 plus I square roots of 3 over 2? And that would be correct. So if you wanted to say 3 plus or minus I square roots of 3 over 2, that would be the same thing. All right? Now let's go back to this form right here and talk about, okay, let's change it to vertex form now. So changing to vertex form, you'll realize the steps are still the same to get to this point. You still move the constant, put the boxes in, find the magic number, factor, and then condense the left. So, but since we're not solving at this point, we're going to bring the constant back over, and then we're going to set it equal to y. And now, check it out, we're in vertex form. Okay, last example. Let's look at how do we complete the square when a is not 1. So how do we complete the square when a is not 1? For the most part, the steps are the same. We just have to add a little because we don't have an a value that's 1. So the first step is I have to kick that constant to the other side. Always, always, always start by kicking the constant to the other side. Now, step 2 is we have to factor the a value out of the left side, okay? Because you cannot do complete the square unless your leading coefficient is 1. So what we have to do is we have to manipulate it so that the a value is 1. So keep in mind, this is not, okay, this is not a GCF. We are simply factoring the a out. Now we have to put our magic boxes in. So I put my magic boxes in for the magic number, but you'll notice over here I didn't just put a box, I put 4 times the box. Because think about it, if I were to redistribute this 4, I'm not just adding a box, I'm adding 4 times the box. So if I add 4 times the box on the left, I have to add 4 times the box on the right. And so that's a little change. So if a is not equal to 1, after you factor a out, on the right hand side you're going to add a times the box, not just the box, so that we can remain equitable on both sides. So now we're going to use b over 2 to find the magic number. So my b value is 2, 2 over 2 is 1, 1 squared is 1. So I put the 1s in my boxes for the magic number. Then I have to factor the left and combine the right. Well, I need two numbers that multiply to make 1 that add to make 2. Well, that's going to be x plus 1 and x plus 1. And then, of course, 4 times 1 is 4, plus 12 is 16. So now I'm going to condense the left side, and I'm going to make that 4 times x plus 1 squared equals 16. Now, here's where the paths diverge, okay, because our paths are the same up until this point. If we're solving, we'll solve for x. But once we get to this point, if we are changing it to vertex form, we'll bring that constant over and then set it equal to y. But the steps to get to this point are the same, regardless of if you're solving or changing to vertex form. So, since I'm solving, I've got to divide by 4. So I'm going to divide by 4 on both sides. That gets me x plus 1 squared equals 4. Now, at this point, I also square root both sides. So that gives me x plus 1 equals plus or minus 2 because I put the radical there. All right, now to keep solving for x, I have to subtract 1 from each side. So I get x equals negative 1 plus or minus 2. Well, negative 1 plus 2 is 1, and negative 1 minus 2 is negative 3. So the solutions to this are x equals negative 3 comma 1. All right, now let's change that to vertex form. So remember what I said. The steps are the same to get to this point. So we're not solving now, we're changing it to vertex form. So remember, all you have to do is move the constant over and then set it back equal to y. And now you're in vertex form. So I know what you may be thinking. You're like, well, in 4.2, we learned to change standard form to vertex form by using the a and getting the vertex. Can we still do that? The answer is yes, but you also need to know how to change it to vertex form using complete the square. Because on your quiz, we're going to say, hey, solve this by completing the square, or hey, change this to vertex form using complete the square. So you need to know both methods. All right, and just to conclude, when will I use this new method of completing the square? Well, you'll use completing the square when the graph does not show the exact x-intercept. You could use it when it's not factorable. You could use it when you can't remember or don't like the quadratic formula. You could use it when it has a when its middle term has x, so when it has a linear term. So when it's not just x squared and a constant. So when you have that x term in the middle, you can't use the square root formula, so you can use complete the square to solve. And lastly, I'm told to complete the square. That's one of the biggest reasons why we use complete the square. And that's it. So your homework is worksheet 4.6, and it will be due at the date specified by your teacher. All right, so I hope everybody has a great day, and we will see you back next time. Thanks, everybody. Oh, please remember, wash those hands, social distance, use hand sanitizer, all that good stuff. Take care of yourself and be safe.